2 says we have a hot air balloon that is rising straight up from a level field. So you get kind of this picture going on. Our balloon is going upward. And a rangefinder is tracking it 500 feet from the point of liftoff. So 500 feet here, and our rangefinder is tracking it. So it's looking at that balloon. You can think of it like a camera or something. At the moment, the rangefinder's angle of elevation is pi-fourths. So right now, our angle is pi-fourths. But it's changing because as the balloon rises, this thing has to change its angle so that it can stay focused on the balloon. And the angle is changing or increasing at a rate is going to be one of our derivative things, so d theta dt, at a rate of 0.14 radians per minute. How fast is the balloon rising at the moment? So I'm going to define a couple other variables in here. I'm going to say that 500 is x, and the vertical is y. Just kind of thinking horizontal is x, height is y. Doesn't matter. Name them whatever you want. You're defining your own variables. So what we're asked for is how fast is the balloon rising? So what are we looking for in terms of variables?
A rate of change of y.
A rate of change of y in terms of time. So we are looking for dy dt. That's what we want to solve for. Now we need an equation that's going to relate all of these variables together. So what is an equation that would relate theta to x and y?
Tangent of theta equals y over 500.
Why did you say 500 and not x? Well, we know what theta is too, so why didn't you just say tangent pi-fourths?
500 is a constant.
500 is not changing. So that's where in the strategy it said we can plug it in as long as it's not changing. That rangefinder is staying where it is on the ground. It's not moving. It's changing in terms of angle, but it's not like getting closer to the point of liftoff or further away from the point of liftoff. So since 500 is staying constant, we can plug it in. But theta is changing and y is changing, so even though we may have values for them, we don't want to plug them in yet. So then the next step on our strategy was to take derivative. So we're going to take derivative of the equation in terms of time. What's the derivative of tangent? So it's secant squared theta. And then for every variable, we need that d theta dt. So secant squared theta d theta dt is the derivative of the left side. On the right side, we can think of that as like 1 over 500 times y. So what's the derivative of that side going to be? 1 over 500 times dy dt. So the constant just hangs out, and then we need the derivative of y in terms of time, so dy dt. At this point, we can plug in anything that we know values for and hope that there's only one thing left, and that is the thing that we want. So secant of theta, theta is pi-4, so we can do secant squared of pi-fourths times d theta dt is 0.14 equals 1 over 500 dy dt we don't know, but that's what we wanted to solve for. So it's good that that's the only thing that's left.
And would you move the 500 over to the other side to make it cleaner, or is it fine as it is?
Good question. hopefully it'll catch up and you'll actually be able to see what it says. If this were a free response problem, yes. Just multiply both sides by 500 and call yourself done. Don't worry about evaluating anything else. If this were a multiple choice question, that's not going to be the answer. So then we would actually need to evaluate it.
If you did, do we have to multiply the 500 over and like put it over on the other side? And then could you leave it there?
In the first problem?
No, for when we actually plug numbers in.
Oh.
If you multiply 5 over, then you don't actually have to do the math. Which is just basically plugging in the calculator, but then you just have the equation without figuring out the numbers. So.
Oh, I hate it when it freezes.
Wouldn't y just be 500 though?
Currently.
Guess what, guys? It's Friday. So
But it's changing because the balloon is rising.
And freshmen have Freshman Friday. So we're going to meet in the choir room again.
And we weren't asked how high is it. We were asked how fast is it rising.
Before we break off in groups. So just hurry and get there so we can get things rolling. Okay, thank you.
Something went away in the corner.
There we go. Okay. Okay, but it won't send back what I had written. So, yeah, so we plug in the values. If it is a free response, we could leave it at just the 500 times secant squared of pi fourths times 0.14 equals dy dt, which is disgusting. But for a free response, totally legit. For a multiple choice, not so much. So pi fourths, what do we know about a pi fourths triangle?
1, 1 squared.
1, 1 square root of 2. What is secant the reciprocal of? Cosine. What would cosine be in this triangle?
1 over the square root of 2.
1 over the square root of 2. So secant would be
Square root of 2.
square root of 2 over 1, and it's secant squared, so we want to square that. So we get then 1,000 times 0.14, which is move the decimal 3 times, 140. And then units, we were told it's rising in feet per minute because our theta was in minutes. The angle's in radians. The 500, that's x on the bottom. We were told that's 500 feet. I forgot to write the feet. So on a multiple choice, you would actually need to do that arithmetic out, which, although it looked disgusting, the arithmetic actually turned out to be not so bad because they picked special nice numbers for us. But on a free response, don't do it even though it turns out to be not so bad, because if you make a mistake, then you lose your points.
Can you do it and then erase it?
You could, but then why even waste the time doing it?
Because you're just like, goes back to you because you're Josiah.
All right, the next